All right, I pulled out a crunchy one just for you guys. Here it is, negative 0.2 tangent of 2x minus pi over quattro. Oh, here we go. So I already plotted or wrote down our table of values for our regular tangent function. And so what I want to do is this. Normally what I've taught you is when we did this tangent and when we did the sine and cosine is I had you rewrite this as y equals negative 0.2 tangents. And then what I had you do is pull out this 2. Remember that? How you would pull out the 2, and then you would have x minus pi over 8. Okay? And which is fine. Okay? I told you to, and then like I told you first to graph this one, right? Y equals negative 0.2 tangents of 2x. How that was step 1, which means to first graph the stretched or the compressed function first, and then do the shift. Okay, that's the way that I taught you with the sine and cosine. But since now we're going on to tangent and so forth, you know what, you could still do this, but just to alleviate less work and maybe confusion with having 2 graphs, let's just do 1 graph. And what I'm going to do is that, like, I'm actually not even going to do this right here. Like, I'm not going to pull out a 2 and do the compression first and then graph a second one. Rather, what I'm going to do is I'm going to deal with the stretch and the compression all at the same time. You're like, oh, dang, dude, that sounds a little hairy. Well, it's actually not too bad. Watch this, okay? So just like we did with the last problem, I'm going to take this guy right here, and I'm going to set this equal to theta, okay? So 2x minus pi over 4 equals theta. And so basically, let's solve for x, and that's how we're going to get our new x values. So I'm going to add pi over 4 to both sides. So we get theta plus pi over 4. And then I'm going to divide by 2 on both sides. Or in this case, I'm just going to multiply by a half. Okay, and that's the same thing, right? I could divide by 2 or multiply by a half. They mean the same thing there. Okay? So really, this is how we get our x values. Okay, is we're going to take theta, multiply it by a half, and then add pi over 8. All right? And let me just write this guy over here. Now, if you're wondering, well, why didn't we do that last time then with sine and cosine? You know what? You could have. But I was really interested in showing you what these meant, and that this one always was going to deal with your stretching or compression, and this was going to deal with your shift. But now that we've kind of learned that, and now we're going on to other functions, I'm going to go ahead and just do it all in one swoop move. You can still go back and do it as we did over here, but this is what's so neat about math, is that there's always more than one approach, and I just want to expand your awesome minds here to the way of doing this. Okay, so this may take a tad bit of work now, because the way I'm going to find x is I have to do all this mumbo jumbo. So to get my first x value, I have to take theta and multiply it by a half, and then add pi over 8. Okay, so let's do a half times negative pi over 2 plus pi over 8. Okay, so all I do is I just substituted theta for negative pi over 2. Well, a half times negative pi over 2 is a negative pi over 4 plus pi over 8. All right, and then we could just get a common denominator right here, right, by multiplying this by 2, multiply that by 2. Oh, I don't like that marker at all. Let's do a little thinner one there. So this is negative 2 pi plus pi, which is just negative pi over 8. All right, and so that's going to be our first one right here, negative pi over 8. And we're going to continue the process here. So a half, right? I'm just doing this, a half times theta, so a half times negative pi over 4. And then I'm going to add pi over 8 plus pi over 8. Well, this right here just gives me negative pi over 8 plus pi over 8, which is a whopping 0. We like whopping zeros. So a whopping 0. Okay. 0 is quite easy. I just plug in 0 here. Half times 0 is 0 plus pi over 8 is just pi over 8. I don't know if you see this here. We're going in increments of pi over 8. This is negative pi over 8 plus pi over 8 is 0. Plus pi over 8 is pi over 8. Plus another pi over 8, that's going to be 2 pi over 8, which is going to be pi over 4. And last but not least, so it's 1 pi over 8, 2 pi over 8, 3 pi over 8. So 3 pi over 8. Now, you could have kind of done it the long way by plugging this into this whole thing, but if you see the pattern here, let's just go ahead and use some common sense there, okay? Now, the way that we find the y values is the exact same way as we found the y values for our sine and cosine. We take these guys and multiply it by negative 0.2. So our undefined times negative 0.2 is still undefined. Negative 1 times negative 0.2 is a positive 0.2. Positive, well, it's supposed to be a 0.2 right there. Okay. 0 times 0.2 is 0. 1 times a negative 0.2 is a negative 0.2. And the undefined right there. Okay? So this right here represents 1 period. So let's go ahead and see if we can come up with a nice sketch here looking at those points. All right, make a line here. Looks like it's going to kind of be on. I'm going to go to the right of it, so I'll kind of make it like this. Alrighty. So let's start with negative right here, negative pi over 8. And then it went to a positive pi over 8. And then it went to pi over 4. And then 3 pi over 8. Now, we know that this is going to have our asymptotes right here, but let's just continue this one more cycle or one more period. And so as you can see here, from negative pi over 8 to pi over to 3 pi over 8, that's 4 pi over 8, which is pi over 2. So our period is really pi over 2. So we're going to go over another pi over 2, which is basically 4 hash marks, right? If I start here, 1, 2, 3, 4. So from here I have to go 1, 2, 3, 4. Okay, 1, 2, 3, 4. If you feel that I kind of explained something too quickly, that's when you're going to want to just rewind it and just listen to it again, because you could probably understand what I'm telling you, but maybe I may go over just a tad bit fast, but the power of the video is for you to rewind it and to see what I said there. Okay, so this is 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8, which is just pi over 2, right? So 3, 4, 5 pi over 8, 6 pi over 8, but 6 pi over 8 is 3 pi over 4. So 5, 6, and then 7 pi over 8. Okay, so basically I'm just continuing the pattern just so that I could have 2 full cycles here. Okay, and I'm just going to call this right here 0.2. Again, you can kind of make your own scale there. 0.2. All right. So right there. Actually, let me go and put my asymptotes in. Let's see. That's going to be at negative right there. We also have one at 3 pi over 8 right there. And we also have one. So it goes 1, 2, 1, 2, 3, 4, and then 1, 2, 3, 4. So we'll have one right here. Okay. So let's go ahead and just plot these babies, and then we're good to go. So at 0, we got 0 and then 0.2, and then pi over 8, 0, and then pi over 4, 2. There's my first guy. And let's do my second one. I'm just transporting or transposing those same points right there. Wow, probably one of my best ones I've done. I mean, not that it's perfect, but a lot better there. And there we have 2 periods. Okay, so if I asked a few questions such as what was the period, we would say that the period was pi over 2. And the way that you can get that quickly is the following. Remember how for sine and cosine? Okay. Sine, for the sine of x, our period was 2 pi over b, right? Well, since now we're doing tangent, it's going to be pi over b. Well, what is my b? My b is 2. And so that's why when you come down right here, it's going to be pi over 2. But the other way of figuring that out is by saying, what's the distance from negative pi over 8 to 3 pi over 8? If I just subtract those two, 3 pi over 8 minus negative pi over 8, well, that's 3 pi over 8 plus pi over 8, which is 4 pi over 8, which is pi over 2. So all kinds of math going on there, but hopefully it should be clear, hopefully, that the period is pi over 2.